One of the challenges and a good thing about Kubernetes is its flexibility. For every Kubernetes resource, you get a lot of options and choices. One of such resources is Ingress Controller. An Ingress controller in a Kubernetes acts as a reverse proxy and load balancer. It implements a Kubernetes ingress. The ingress controller adds a layer of abstraction to traffic routing, accepting traffic from outside the Kubernetes platform and load balancing it to pods running inside the platform. In this video, we are going to look at different ingress controllers available in the market, and then we will look at the criteria as on the basis of comparison. Before I delve into the detail, full disclosure, this video is based on the CubeDex article and to which I will put the link in video's description later on. So as you can see on the screen that on the left hand side in the first column there is a criteria, and then in the column names are different ingress controllers available in the market. Before we start comparing these ingress controllers, let's have a quick look at what exactly this criteria is. Because in order to make a high grade comparison and to get some useful results, you have to have a good understanding of these all items. So the first criteria on which we are comparing these English controllers is supported protocols. As it is evident from the name, supported protocols involve a lot of industry standard protocols, and this is a fundamental parameter for making your choice. You need to think that will a regular HTTPS proxy be enough for your software, or does it work through gRPC or even HTTP2? Maybe it also needs TCP or even UDP. If your case is non-standard, make sure you consider it thoroughly so that you won't have to reconfigure the cluster later. Each controller has its own set of supported protocols. And as you can see that um, on different for different controllers, for example, in Nginx you have like HTTP, UDP, TCP, and but there is no TLS. So if you look at Glue and Ambassador, then you will see that it supports a lot of them. If you look at Istio, which seems to have even Redis and MySQL there as a support. Okay, next criteria is that what exactly is the underlying software of these controllers. There are several types of applications that can be at the core of the controller. Popular ones are Nginx, Traffic, HAProxy, Envoy. For example, on your screen you can see that both Kubernetes native Ingress controller and Nginx are based on Nginx, also the Kong. But a lot of them like Contour, Istio, Ambassador, Glue are based on Envoy. Okay, then we have traffic routing. You need to understand what is the basis of the decision on routing traffic to a particular service. Usually you can employ host and path, but there are additional possibilities as well. Does matching these values support regex, the regular expression as well or not? And if your use case is complicated one, then you may then the Ingress controller like Voyager or HAProxy might not be feasible because they only support host and path-based traffic routing. Whereas if you look at traffic or something like that Glue, they are quite advanced. Okay. Next criteria you need to keep in perspective is namespace. Namespaces provide a way to logically separate resources in Kubernetes. There are ingress controllers that must be installed in each namespace separately because they allow traffic to the pod belonging to the namespace only. And then there are those that operate globally for the entire cluster. And I believe that as the time is passing, namespace oriented ingress controllers are becoming rare. For example, Kong is specified namespace, but most of them, if you look at this diagram, support the whole cluster. Then We have something called as upstream probes, or how do you direct traffic to healthy instance of an application it services. There are solutions with active and passive checks, retries, circuit breakers, custom health checks, and it is a very important parameter if you have strict requirement for availability and prompt removing of failed services from load balancing. And then related to this, we have something called as load balancing. So for the load balancing, there are a lot of algorithms. We have traditional round robin. We can do something modern one, RDP cookie, or even sticky sessions are quite common in this category. And then if you look at the diagram, you will see that there are a lot of other options in terms of load balancing are available, and the products like Traffic and Voyager, also the Istio one, they provide a lot of load balancing options. Okay, then we have authentication. What sort of authentication scheme your controller support, and with respect to that, what your application needs? Is it basic, digest, OAuth, external auth? What sort of requirement your application have? First, think it from the perspective of your own application, and then check which controller product suits your need. This is an important parameter if you use many environments for developers, and then you also have some private tiers for different teams. Okay, then we have something called as traffic distribution, and then we already saw that you can distribute it through different sort of methodologies like canary, A/B testing, mirroring and shadowing, and a lot of other things which are quite common these days. Then also make sure that you check out the pricing. Is that a paid version or simple free open source thing? Is there technical support available or not? So on and so forth. Also make sure that if you and your team are more comfortable with GUI, then if this controller provides a GUI admin page or not. Um, then for the JSON web tokens, check out that if that is requirement, that is there a built-in validation of JWT or JSON web tokens for authentication, if that's what your application is using. Then we have something called as customization config, expandability of templates in sense of having the mechanism that allow you to add your directives to standard configuration templates. Then there are some things about security like DDoS, request tracing, WAF. If that is your WAF is a web application firewall, layer 7 firewall. If that is what your needs are, then make sure your Ingress controllers need them. So as you can see from this diagram and comparison, that you need to have a complete understanding of not only your application requirements but what sort of products are there. Having said that, Kubernetes official Ingress controller is quite easy to use. It is very mature and offers nice feature, and I believe that is more than enough for a lot of use cases. If that is not what you need, then maybe look at Nginx, and even if Nginx doesn't um, fulfill your requirement, then start looking at other products. For example, take a look at Traffic and HAProxy if there are increased demand for balancing and authorization methods. Both of them are open source projects and they are proven over the years. Contour has been around for a couple of years, but it is still young. Also, another note on Envoy-based products. Envoy-based products have the richest set of features, especially Istio. It is a complex solution that can do almost anything in terms of ingress and much more. But it is quite a challenge to configure it and operate it. And then in some other cases, maybe Glue might be an option because it also has got a lot of option, but they're only the paid version. Skipper can be a good solution too. So if you look at the trends, what exactly the Kubernetes community is using worldwide, then you can see that for the normal use cases, Kubernetes own Ingress controller and Nginx popular, but on the enterprise advanced level, Istio and Traffic are very popular. and then Kong and HA proxy come second. But they are not much in vogue these days, and I am seeing that more and more people are moving away from them for some reason or another. Well, I hope this was useful. If you have any comments or feedback, please put them down in the video.